Unit 4, Lesson 3, Angles in Standard Position. We're going to start by going through some definitions. So for an angle to be considered in standard position, all that means is that the angle is drawn on what's called a Cartesian grid. So that this here is a Cartesian grid. The other thing that you have to keep in mind is an angle in standard position always starts at the positive x-axis. So for example, these two angles here are both in standard position because they're on the Cartesian grid, and both the angles start on the positive x-axis, and then the angle is drawn from that side. Okay, so to make an angle on this Cartesian grid, we need two arms. We need an initial arm and a terminal arm. So the initial arm starts the angle off. Okay, and it's always going to start on that positive x-axis. And then the terminal arm is the arm at the end of the angle. So the rotation of the angle happens between those two arms. Okay, likewise here, the initial arm is always on that positive x-axis for it to be in standard position. That's where the angle rotation starts, and then it finishes at the terminal arm. Okay, we can also create positive angles and negative angles on this Cartesian grid. So a positive angle is an angle that again starts at that positive x-axis with an initial arm, and then the angle rotation follows a counterclockwise rotation. So all positive angles always start at the positive x-axis and go counterclockwise. That is a positive angle. A negative angle still starts at that initial arm, which is on the positive x-axis, but then to create a negative angle, you go clockwise. Okay, it's also important to know that the Cartesian grid is divided into 4 quadrants, okay? And the quadrants are just separated by the x and y axis. So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Very important to know that order and be able to identify quadrants by their number names. Example 1. Sketch each angle in standard position. So that just means that we're going to draw an angle on a Cartesian grid, and we're going to make sure that we start our angle with the initial arm on the positive x-axis. Okay, so let's find 60 degrees using our protractor. Okay, so I've drawn my initial arm on the x-axis. Now you're going to take your protractor, measure 60 degrees, and end off this angle with your terminal arm. Okay, so there's my terminal arm. So there's angle theta at 60 degrees. Okay, alpha equals 420 degrees. All right, so we start by drawing our initial arm on that x-axis, and now we're going to use our protractor to calculate 420 degrees. Now, we know for sure that this angle is going to take one full rotation because it's greater than 360. So what I would do is I would draw in my full rotation, but then I need to know how much more of a rotation this angle takes to get to 420. So I'm going to subtract 360 from 420, and whatever's left over is that extra piece that I now need to include. Okay, so it's 60 degrees, so that means there's a full rotation plus another 60 degrees. Okay, so there's the angle of 420 in standard position. Okay, negative 300 degrees. So we're going to start by putting on our initial arm. Okay, now because our angle is negative, I know that I'm going to take a clockwise rotation from that initial arm. Previously, we've always been taking a counterclockwise rotation because the angles are positive. So let's go ahead and find our terminal arm by starting at my initial arm and rotating 300 degrees counterclockwise. So there's 90 degrees, there's 180, there's 270. Okay, now there's going to be 30 degrees more. So there's my terminal arm, and that's negative 300 in standard position. So I want you to look at all 3 parts to this question and ask yourself, is there something similar between each of these angles? Okay, the first one we were sketched was theta equaled 60, and it turned out like this. Alpha equals 420, and it turned out like this. And this was an angle of negative 300 degrees, and it turned out like this. What's similar between all 3 of those angles when they're drawn in standard position? Okay, hopefully you notice that the terminal arms of each of those angles are in the exact same spot, right? They're all at a position that forms a 60-degree angle with the initial arm. When you have a bunch of different angles values that have a terminal arm in the same position, they are called co-terminal angles. Something that you can also start to notice, and we're going to elaborate on later, is what I said before, right? Not only do they share a terminal arm, but the terminal arms also form 60 degrees with the initial arm. Okay, keep that in the back of your mind for something that we're going to talk about later. Now, if you're not convinced that this can happen just from drawing the angles in standard position, let's take a look at example 2. Let's take the sine of all of those angles from above. So we're going to take sine of 60, sine of 420, and sine of negative 300. And let's see what happens. So this is a time when you can take out your calculator, because we're going to use our calculator to prove this. So go ahead. Type those into your calculator, let me know what you get. You're going to notice that you get the same value for each ratio. You get 0.866. Okay, and that further proves the existence of coterminal angles, which I should have written here, not arms, coterminal angles. Okay, example 3. Sketch the angle of negative 210 degrees in standard position, and then state one positive and one negative coterminal angle. So let's start by sketching negative 210 degrees. So let's start by drawing our initial arm on the positive x-axis. And then because it's a negative angle, we're going to take a clockwise rotation, 210 degrees. Okay, so we're going to go 90, 180, and there's 30 degrees left over. So there's our terminal arm. Okay, so now the question is asking us to also state one positive and one negative coterminal angle. So we need to find two other angles that share the same terminal arm. So any angle that will end up in that same spot. So let's start with the positive coterminal angle. Okay, so we know it's going to start at the same initial arm. And we have to come up with an angle that rotates counterclockwise and ends at the same terminal arm. So a good one to pick would be starting here and ending here. Okay, and we'll call that angle A. So angle A is going to be equal to 360 minus the magnitude of our angle in standard position, right? 'Cause it's what's left over. So an example of a positive coterminal angle is 150 degrees. Now to find another negative coterminal angle, so we need to again start at the initial arm, rotate clockwise, and end at the same arm. Well, we can't just do that because that's 210. We already have negative 210. We need another negative coterminal angle. So let's just keep going around a full rotation of 360. Right? If we just keep going, we're going to end up there again. So one trick to finding coterminal angles is just adding or subtracting 360. Okay, so if you have an original angle and you need to find a negative coterminal angle, you could just subtract 360. Likewise, if you need to come up with a positive coterminal angle, you can add 360. So to find angle B, which is going to be our negative coterminal angle, we're going to take our original angle and we're going to subtract 360. Okay, and we approached solving for this angle a little bit differently than I just explained. Okay, but the method I told you would work as well, right? Because we were asked to find another positive coterminal angle. So our original angle was negative 210, and the little trick I told you is to find a positive coterminal angle, just add 360. So you could have gone negative 210 plus 360, and you would have got 150, the same thing. Okay, so whenever you have to state a positive or negative coterminal angle, just add or subtract 360 to the original angle. Okay, the next part of the lesson is just a few more definitions. So I want to teach you about the difference between principal angle and related acute angle. So if you're asked to graph 150 degrees on a Cartesian plane, you'd go ahead and do this. Okay, so I had my initial arm on the positive x-axis, then I rotated the angle 150 degrees in the positive direction and finished off the angle with my terminal arm. So the principal angle refers to that angle because it is between 0 and 360 degrees. Okay, so 150 would be your principal angle, and we'll call that theta. Now there's a special name for the angle that is formed between the terminal arm and the x-axis. So it can be either side of the x-axis. That's called the related acute angle. We label that as beta. So the related acute angle is the acute angle that is formed between the terminal arm of the principal angle and the x-axis. Let's try another one just to see if you can identify a related acute angle. Okay, so I have 205 degrees plotted in standard form. This would be my principal angle. Okay, the related acute angle here is the acute angle between the terminal arm and the x-axis. Okay, so there's my terminal arm, there's my x-axis, so this must be my acute angle, my related acute angle. Okay, so how to find the related acute angle for a given principal angle? And it all depends on where the terminal arm ends up. So what quadrant the terminal arm is in. For example, if the terminal arm is in quadrant 1, like we have here, right? Here's my terminal arm that's in quadrant 1. The related acute angle as the principal angle. So the related acute angle, denoted as beta, is the same as the principal angle, right? Here's the principal angle. That's also the acute angle that's between the terminal arm and the x-axis. So it's also the related acute angle. Okay, if your terminal arm ends up in quadrant 2, like it did right here, this is your principal angle. We call that theta. Obviously, this is your related acute angle. So to calculate the value of that related acute angle, it's always going to equal 180 degrees minus your principal value. Okay, if your terminal arm ends up in quadrant 3, like in this example, to find the value of the related acute angle, which is right here, you're going to take the value of the principal angle, which is this guy right here, and you're going to subtract 180 from it, and then whatever's left over is that related acute angle. Okay, if your terminal arm ends up in quadrant 4, like in this example, to find your related acute angle, which is right here, you're just going to go 360 degrees minus your principal angle, and then whatever's left over is your related acute angle. So keep these 4 techniques in mind when you are solving for related acute angles. And some of you will just know it, no problem. Some of you need to see this visual, this little breakdown that I just gave you. Okay, so our last example. Let's determine the principal angle and the related acute angle for each of the following. Okay, so let's sketch 120 degrees on this Cartesian plane. So I'm going to start with my initial arm on the positive x-axis, and then I'm going to rotate counterclockwise 120 degrees. Okay, so there's 120 degrees. So that means that my principal angle has to be 120 degrees, because my principal angle is the angle that's between 0 and 360. Now my related acute angle, since the terminal arm is in quadrant 2, that means to find the value of that related acute angle, you're going to take 180 and subtract 120. So that means the value of our related acute angle is going to be 60 degrees. Let's plot negative 310 on the Cartesian grid. So you're going to start with an initial arm on the positive x-axis, then you're going to rotate clockwise because it's negative 310 degrees. So the way I like to look at it is 310 is 50 degrees away from being a full rotation. So that means I just need a leftover piece of 50 degrees. Okay, so that can help you when figuring out where your terminal arm goes. Okay, now to figure out the value of this related acute angle, it's going to be 360 minus 310, right? Because it's one full rotation, take away that partial rotation to 310 degrees, and then whatever's left over is going to be the value of our related acute angle. So in this situation, be careful not to say that the principal value is negative 310 degrees, right? Because that is not the case. Our principal value has to be between 0 and 360 degrees. So our principal value here is the same as our related acute angle. So let's calculate our related acute angle. So related acute angle is going to be 360 degrees minus 310 degrees. So our related acute angle and our principal value are 50 degrees. Okay, 550 degrees. Let's plot that. So that's one full rotation of 360 degrees plus another 190 degrees in the positive direction. Now, again, our principal value is not 550 degrees because that's not between 0 and 360. So the principal value is going to be this angle right here because that is the angle that is between 0 and 360 degrees. So to figure out our principal value, we're going to take 550 degrees and subtract that full rotation. And then the value that's left is our principal angle. Now that we have our principal angle, we need to find our related acute angle. So the related acute angle here is the angle right in here, squished between the x-axis and our terminal arm. So to figure out the value of our related acute angle, we're going to take our principal value, so 190, and subtract 180. Right, and if you forget why we do that, look back up to the example we did before. It explained that if the terminal arm is in quadrant 3, you take the principal angle and subtract 180. Some of you will be able to just look at this and know that that's what we do too by the position of the arm. So our related acute angle here is 10 degrees.